Good morning, students. Today we are going to study about square and square roots, and the topic for today is perfect squares. In previous classes also you have studied about the square of many natural numbers. For example, 3 square, that is 3 raised to the power 2, or 3 square. So if we open it, we write it as 3 into 3, and the answer is 9. So here the base is 3 and the power is 2. So we call it as 3 square. Now if we talk about 3 to the power 3, then that can be written as 3 into 3 into 3, which the product is 27. Here the base is 3 and the power is 3. So whenever power is 2, we say that it is the square of a number. Now the square of a number is the product obtained by multiplying the number by itself. For example, 1, 4, 9, 16 and 25 are square numbers. Now let us understand this by a simple activity. All you need is some square slips. So just have a look. I have one square slip. So it is forming a shape of a square. So we'll say yes, 1 is a square number. Now what I'm going to do is I'm going to arrange two square slips. So I will arrange the second square slip just adjacent to 1. So this is my second square slip. Right? Now we can see the shape of the resultant figure is not a square. Now again I have arranged my third square slip. So this is my third square slip. So we can see that the shape is again not a square. Now after placing the fourth square slip, I can see that the resultant shape is a square. So next square number that can be arranged in a shape of a square is 4. Now after that we are going to place 5, 6, 7, 8 and 9 square slips. After placing 9 square slips, we found that the resultant shape is a square. So 1, 4, 9 are my square numbers. So next square number will be 16, and after that square number will be 25. So a given number is called a perfect square or a square of a number if it is the square of some natural number. Now let us find the square numbers through an activity. For that we need a square paper like this. This is a square paper that we would be needing, and we would be cutting it down into 15 by 15 grid like this. So this is a 15 by 15 grid, and we are going to write the numbers in it. Let's see how. We are going to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Similarly, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now we are going to multiply the two. Let's see how we are going to multiply. 1 ones are 1, 1 twos are 2, 1 threes are 3, 1 fours are 4. Corresponding the digit from the row to the column. So if I'm standing here, I'll be multiplying the number of my row with the column. So 1 into 5, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right. So we are going to complete this grid in this way. The remaining grid you will be completing yourself. Now let us find the perfect squares. Our task is to find the perfect squares. So my first square number is 1. What I'm going to do is I'm going to shade that square. So my first number is 1. Now just observe the pattern. This is how I am completing my square. So how many squares are there? 1, 2, 3, 4. So my next perfect square is 4. Alright. Now again my next complete square will be 1, 2, 3. That is 3 by 3. So let me count the number of squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my next perfect square is 9. You can see that we are getting a diagonal. So my next square is 16. And 16 comes by 4 into 4. So 1 is 1 square. 4 we are getting as 2 square. 9 we are getting as 3 square. 16 we are getting as 4 square. And my next square number is 25. That is 5 into 5, 5 square. Next square number is 36. That is 6 into 6, 36. So my next square number will be, just fill the grid and paste it in your notebooks. Now my next task is to check whether a given number is a perfect square or not. For example, if I ask check 256 is a perfect square or not. So the technique to check any number is a perfect square or not, what we are going to do, we will be doing prime factorization of it. So we all know how to do prime factorization. So prime factorizing it, we start from 2. So this is 2 ones are 2, 2 twos are 4, 2 8s are 16. Again 2, 2 6 are 12. Again 2. That will be 2 6 are 12, 2 8s are 16, 2 4s are. So 256 can be written as 2 multiplied by 2 8 times. And after making the pairs, we find that no factor is left. All the factors are made into pairs. So since no factor is left unpaired, we can say that 256 can be written as 2 into 2 into 2 into 2 to the power 2, that is 16 to the power 2. Yes, 256 is a perfect square. Now let's check whether 720 is a perfect square or not. So again, what we are going to do? Prime factorization of 720. We'll start with 2. 2 3s are 6. 2 6 are 12. Again 2. 2 1s are 2. 2 8s are 16. So 720 can be written as 2 into 2, 2 into 2 into 5, 3 into 3. Now let us make the pairs. That is 2 into 2 form one pair, 2 into 2 form one pair, 3 into 3 form one pair. And we have one unpaired factor left. So since 5 is left unpaired, therefore 720 is not a perfect square. Now this was the method by prime factorization. We have certain properties also that even by looking at the number without finding its factorization, we can tell that whether the number will be a prime factor, will be a square number or not. Let us see how. So there are certain facts that will tell you about perfect squares. So my first fact is, if the number ends with an odd number of zeros, if the number ends with an odd number of zeros, then the number cannot be a perfect square. For example, if I talk about 1000, the number of zeros equal to 3, that is odd. So 1000 cannot be perfect square. If I talk about 640000, number of zeros, that is 5, which is odd. This is not a perfect square. So therefore any number ending with odd number of zeros cannot be a perfect square. Next fact is, the numbers ending with 2, 3, 7, 8 are not perfect squares. For example, if I write any number 1442, since the number is ending with 2, it is not a perfect square. If I write any other number 243, it is not a perfect square. 747, not a perfect square. 648, not a perfect square. If I write 346. Since the ones place is neither of them, neither of 2, 3, 7, 8. So I am not sure whether 346 is going to be a perfect square or not. I'm not sure whether 346 is a perfect square or not. What I have to do is I have to check it by prime factorization and then I'll be sure about it. So my fact says that if the number ends with 2, 3, 7, 8, then definitely the numbers are not going to be perfect squares.